analysis. It cares about every single point. It finds the best line it can, thinking when it considers every single one of your data points. Therefore, it'll be more accurate. You can have multiple regression where you have more than one relationship. We'll focus on simple regression where it's just one relationship. What you're trying to do is minimize the sum of the squares. No, can't do that by hand. So there are an infinite number of lines that can be drawn, right? An infinite number of lines that could be drawn with these dots. You could draw a line that looks like this. That could be a regression line, but it would not be the least squares regression line. The least squares regression line, and let's assume for the moment that this is a least squares regression line, just for discussion purposes. It takes every single point and measures its distance from the line. That's on. Now, it's possible to have a lot of different lines when you just added, well, what you want to do is get the line that takes this distance, as measured over here, and has the smallest total difference. The reason why you have to square it is because some are negative and some are positive. If you don't square it, it's going to be 0. You'll have the same amount of distance below and above. But by squaring each of these distances, it gets rid of the negatives. And so you look at every possible line until you find the line that is the least of the squares of these individual distances. And that is the best possible line that you could draw, the optimal line for those data points. It's still subject to some degree to outliers, but not nearly as much. If you had a bad data point down here, it's going to be a big line. It's going to change the focus. But it's just 1 of 12 points now. It's not 1 of 2 points. So